Hey guys, it's me, Jerry, and this here is Jace, and we are Precal pals. Oh yeah, ain't that right, Jace? Jace, you are too funny sometimes, man. Gosh, this guy, just so funny. Jace, you are so funny, man. Woo! You crack me up. Anyways, today we're gonna be going over exponential growth and decay functions. So one's growing and one's decaying. So what's that gonna look like? Well, Jace right here, our little comedian, is gonna explain that for us.
All right, so right here we have exponential growth function. So this 172 inches represents how tall a tree is.
Hi, post-production Jerry here. So what Jace is talking about is the example problems that we had failed to actually mention. So I would like to clarify those now. The example problem for our growth function is a tree that measures 172 inches is growing 73% annually. And our question is, how big is it after 4 years? And also, our decay function is a small town in Wisconsin with a population of 747 people is shrinking at a rate of 24% annually. And our question is, what is the population after 4 years? Okay, thank you. That's it.
The 73% represents how much it would grow in 1 year. Then this 4 is how much is the time period. So after 4 years, how much would it have grown at a rate of 73% is what we're trying to figure out. The formula for this would be final amount, which is F, times T, which is just the time, equals amount 1 plus the rate, which would be the 73%, to the power of T, which is time. So when you come here, it would be F of T equals 172, open parentheses, 1 plus 0.73, as you need to turn this 73% into a decimal, close parenthesis, to the power of 4. When you put this into a calculator, you would get, sorry, not F of T again, let me get this. It would be F of 4 equals 1,540.68 inches. And that's how you would do an exponential growth function.
Okay, thank you, Jace.
You're welcome, Jerry.
All right, so now we're gonna go over the exponential decay functions. It's going down. So in this situation, we got a little city, probably Wisconsin, with 747 people in it. And it's dying, okay? It's decaying at a rate of 24% annually. So in the span of 4 years, how many people are there? Let's find out. So we start with FT equals 747, parentheses, or times, I should say, 1 minus 0.24, which is just that, turned into a decimal, to the power of 4. So then that turns into, what does that turn into again? 248.22. But since we can't have a fraction of a man, we round this up to 9. So we have 249 people after four years.
Thank you, Jerry.
Yeah, you're welcome, Jason.
So this is what our equation looks like. So if you just go over to the graph, that's what it would be. Then to find the value you need to go over to the table. Then we have the value of 4, which would be the 1,540.7.
Thank you, Jason.
You're welcome, Jeremiah.
All right, so now for the decay one, we got the equation right here, 747 with 1 minus 0.24 to the power of x this time for the calculator. Okay, so as we can see, it decays right here. So now, if we go to the graph and we go to 4, we see the answer, which we should be rounded to 250. So it is correct.
Thank you, Jeremiah.
Yeah, you're welcome, Jason.